All right, so y'all, this is a problem from the review. This is actually number 16 out of the review, and the student did the problem. They actually got it right, but they wanted me to go over it just to make sure that they had a good understanding. So let's see if we can figure this problem out. It says, use the normal distribution of SAT critical reading scores for which the mean is 505. Okay, so the first thing I'm going to do, I know my mean is 505, and our standard deviation is 119. It says, assume that variable x is normally distributed, and part A says, what percent of SAT verbal scores are less than 600? So for part A, what we're trying to figure out is what's the probability that x, which are those verbal SAT scores, are smaller than 600. Okay, the first thing we're going to do here, y'all, we're going to convert this x value to a z-score. So the way we do that is we go x minus mu, all divided by sigma. So my x number in this case is 600 minus 505 divided by 119. Okay, so let me get my calculator, let me clear all this stuff out. So I'm going to go 600 minus 505 divided by 119. Okay, and I'm going to go math, decimal. Okay, so I'm going to go ahead and just write down 4 decimal values. I'm coming up with 0.7983. Okay, so z is 0.7983, something like that, right? Let me double check my numbers. Yeah, 7983. Okay, so now what we're going to do is we're going to figure out what's the probability that z is smaller than 0.7983. Okay, just to give you a visual, this is what we're doing here. I'm going to draw my standard normal curve, right? Looks something like this. Here's 0, here's 1, here's 2, here's 3, here's a -1, a -2, and a -3. So the value that we're looking at is 0.7983, probably somewhere right about here. Okay, 0.7983. Since it's saying that z is smaller than, what we're really looking for here, y'all, is we're looking at the area to the left of that value. So I'm trying to figure out what's the area under the curve to the left of 0.7983. If you remember this, when we would do these problems, we would say, look, over here is negative infinity and over here is positive infinity. So the way we're going to do this part on our calculator, y'all, we're going to go with a normal CDF, okay? And since we're going all the way to negative infinity, remember, we would use our lower number to be negative 9999, and then our upper number, we're stopping at 0.7983. So let me do this step on my calculator. So I'm going to clear this out. I'm going to go second in bars, normal CDF, negative 9999, comma, 0.7983. And I'm coming up with a 0.7876. Okay, 0.7876. So I'm going to write that number in blue. Oh, I'll write it right here, 0.7876. Now, the question is asking us what percent. So this is the value as a decimal. As a percent, y'all, it would be, move my decimal 2 spaces over, 78.76%. And if you notice, that's the same answer that the student got for part A. Okay, now let's do part B. So part B says, if we had 1,000 SAT verbal scores were randomly selected, how many would we expect to be greater than 525? Okay, so for part B, what they're saying is, what's the probability that x is bigger than 525? Just like we did before, we're going to convert this x value to a z-score. So I'm going to say z equals x minus mu divided by sigma. So my x is 525 minus mu, which was 505, and sigma, which was 119. So let me find this as a decimal. So 525 minus 505, 05 divided by 119. And let me make that into a decimal. So I'm coming up with like 0.1681. Okay, 0.1681. So 0.1681. So now what we're going to say is, what's the probability that z is greater than 0.1681? Okay, let me draw a picture here as well, just like we did before. Oh, that's a pretty ugly normal curve. Let me fix that. I'm embarrassed on that one, guys. Sorry about that. Okay, here we go. This looks a little bit better. Here's my 0, 1, 2, 3, minus 1, minus 2, and minus 3. Okay, so again, look at the number we're looking at, 0.1681. That's just on the other side of 0. 0.1681. And my arrow is pointing to the right. So we're trying to find the area to the right of 0.1681. Remember over here, y'all, is negative infinity. Over here is positive infinity. So when I do this on my calculator, I'm going to go with my normal CDF, right? Where are we starting off at? Oh, my lower limit now is 0.1681. And if we're going all the way to infinity, remember we would use 9999, okay? So let me do this step on my calculator. So I'm going to clear this out. Second vars, normal CDF, 0.1681, all the way to the nines. And I'm coming up with like 0.4332, or 33, I would say, 0.4333. So 0.4333. Now, when I look at the question, it says, if we had 1,000 people, how many would we expect to be greater than 525? So what I'm going to do now is I'm going to take this number, 0.4333, and we're going to multiply that by 1,000. So I take my calculator again, 0.4333 times 1,000, and I'm coming up with 433.3. So since we're actually looking at how many, it would just be 433, right? We're not going to round it up or anything, but that would be my answer for part B. And if I come back over here and I check, hey, same number right there, okay? So again, if y'all have any questions, let me know. You know I'm happy to help.